Okay, I think we're ready to start. I'm John Dyer, and I'd like to say welcome to the start of the closing day of the conference. I think it's really nice to see so many people enjoyed themselves at the brewery last night. It's not so gratifying to see the results this morning. But I'd like to thank the people in Poland, PSNC, for the excellent reception and event that we had last night. We've got some housekeeping slides. So we did have some housekeeping slides playing on the screen above. The one thing I would like to remind you about is the online evaluation form. So if you can try and complete that sometime today, I'd be very grateful. We've got three excellent speakers this morning. The subject of the session is campus networks, and it may seem odd to see Dyer, who you all know has been operating the backbone, international backbone for some time, to speak to us on campus networks, but I'm sure that he'll be able to convince you that he's got his tentacles into the campuses with the end-to-end initiatives. So, Dyer.
Good morning, ladies and gentlemen. In fact, I have very little sort of knowledge or insight into campus networks, which is why John's comments about it's odd to see me speaking here is really quite relevant. But what I'm looking at is the campus from the inside of the pan-European network and also via the national networks. And historically, with an IP environment, networks can exist more or less independently one of another, and the service essentially works. With the developments on a pan-European and on a global scale with point-to-point services, then the networking environment is changing from the middle rather than from the edges. And it's really the networking environment changes in the middle and the effect that they will potentially have on the campus environment that I want to cover today. And I think it's quite interesting to see that historically it has been the local networks where you had maximum innovation. There's been a number of reasons for that. One is that, in fact, national and international networking has historically been restricted by regulation. Now, with a very competitive market and very global technology, it is in some senses easier to develop a pan-European network than it is a campus network. And so from that point of view, the developments on a global scale are actually starting to influence where we are in respect to the campus networks. I think what is interesting in terms of Géant 2 and the potential effects it will have in terms of the global requirements for networking are really 3 points. There is the service portfolio, and then there are issues in respect of performance and measurement, and I'd like to cover all three this morning. The service portfolio issue is interesting in as much as historically you had an IP service, and an IP service worked. It worked well or it worked less well, but essentially it always worked. Now, with point-to-point services, that is a very different sort of networking environment. As far as point-to-point services are concerned, they can fail, and they can fail disastrously. So from a very practical point of view, you have to look at point-to-point services very much on an end-to-end basis. And really, there are two significant types of point-to-point services that will be available on the pan-European backbone. I think the most significant from a campus point of view is switch gigabit Ethernet. The reality is that something that you can build into your assumptions in terms of what is available on a pan-European basis. There are also wavelength services that you can operate on the pan-European backbone, and in principle at 2.5 or at 10 gigabits a second. So that the portfolio of services has moved away from best efforts IP, maybe less than best efforts IP, and IP quality of service, to an environment where you can offer, certainly on a global basis, end-to-end in terms of the pan-European network or the national network, a range of point-to-point services. It's not too difficult to do some simple mathematics and sort of look at the Géant 2 backbone and realize that there are not many campus users that are going to want 10 gigabits a second. At least I hope they're not, because in practice there are about 5 or 6 wavelengths on each route maximum that are built into the network. So that is not practically the main issue, but gigabit Ethernet I think is interesting. And gigabit Ethernet is interesting because it is a workable technology, it's a standardized technology, it's a technology that's available on a lot of machines. And the demand for that sort of switch service is certainly something I think you will see emerging in terms of the requirements of your users on campus. Because it is available, it will be a global service in the next 1 to 2 years, and that practical reality means that you will see demands at a campus level for the building of gigabit Ethernet type services. So I think from a portfolio point of view, the significant development which is happening on the national research networks and on a global scale is really a move away from pure IP as being the only communication mechanism to an environment where gigabit Ethernet will play a significant and increasingly important role in terms of the services that people demand. And I think that's the practical development which will affect you most in terms of technology. In terms of operations, though, there are also some quite significant developments in the context of the Géant project, which move away from isolated network operations environments to one where you will take a much more end-to-end look. And historically, network performance problems have always been in the backbone network, whether it was the national backbone or the pan-European backbone, because capacity was always expensive, capacity was always under-provided there, and so it was very easy to blame the backbone network for performance issues. But now, if you look at the sort of capacities that are available in national and global backbones, those capacities are never fully utilized. And so performance problems, which historically have been very easy to pin at the network, at the backbone network, the wide area network, really that criticism can't apply. You just look at the capacities available on the Géant network today and the capacities that will be put on the Géant 2 network tomorrow, and you look at the utilization and you realize that the performance issues are not simply a question of backbone capacity, because backbone capacity is a problem that has really been solved for 3 or 4 years now. And so you have to look much more at the total end-to-end system and understand how that end-to-end system is concerned, including the computers, the campus networks, the national networks, maybe metropolitan networks, and the pan-European network, to understand where performance problems are hitting and where the difficulties are. The simple analysis which says it's the wide area network capacity just doesn't apply anymore. And performance problems are a very practical issue, which we see on a regular day-to-day basis. You find that configurations which you would expect to work and to yield point-to-point connectivity of hundreds of megabits a second, when you actually try them, you in fact find that you get maybe 20 or 30 megabits a second, and the question is why? And this very practical issue says all the components are there, all the components work, but when I put them together as a system, I do not get the performance. This is a very practical issue which one starts to see now. And so what we're looking at in terms of solving it is to provide much more emphasis on performance and to provide a team of people that will actually look at performance issues, both in the context of national networks and in the context of the Géant 2 activity. The Performance Enhancement and Response Team, or PERT as it's called, is one of the major innovations in terms of operations which you will see in the context of Géant 2. I think it's interesting, if you look at the history of it, that this idea was conceived in the States around about the turn of the millennium. And in practice, what is happening is the first realization of this is in the context of Géant 2, where the national networks and Dante are building together a team of experts that will provide support for performance problems. Really, it is to provide not just networking support, but also support in terms of operating systems and general systems support. And this is one of the significant developments in terms of the portfolio of support activities that will be part of Géant 2. And one of the interesting things is there will be T-shirts with PERT written on them as well. So that gives you a degree of encouragement to take part in these activities. What you have is a team of people that are built up where people own performance issues. And that's the first thing I think that is important. If there is a performance issue which covers the European space, then there will be somebody that owns that from either the participants in the Géant 2 project. And that will be something where it is supported by, for example, performance trouble tickets and a development in terms of the support systems that will concentrate not just on success or failure, but also on performance problems. And in addition to that, there will be expertise available looking at different operating systems and other areas of performance to understand the relationship between the different elements in the chain. And so moving away from the idea that any connectivity is acceptable to an environment where performant connectivity is something that you can expect. And this emphasis on performance is something that obviously is end-to-end. You have to look at the entire picture from machine to machine, from communicating machine to communicating machine, via the campus environment, via the national environment, and really you have to look at all of these elements because it's only when you take the complete picture that you can solve performance problems. So the main point about performance is it will be something that is part of the technical agenda that is being developed in terms of national and international networks, and you can reasonably expect that your demanding users will be wanting support in this area. There is the development of underlying systems to provide that support in terms of virtual teams of case managers and in terms of providing expertise in the different operating systems to help debug these things. It is one of the realities of life that as you build bigger, better networks, you enable people to do more performant things, but in practice, you do need to work at getting that performance at tuning. So that's one of the important developments in terms of the way network operations will change in the context of Géant 2, that there will be the ability to look at performance issues, there will be support for performance problems, and it's something that you can, I think, reasonably expect to see and to exploit from your own point of view. The other thing which is important, and again this was something I picked up in listening to one of the talks yesterday, is that there is very strong interest in understanding how the network as a whole is performing. And the network as a whole is not just a backbone network, it's not just a national network, it is the end-to-end network. And there has been quite a lot of development work going on looking at network performance monitoring, and really to understand the way the network is operating on behalf of its users. Historically, this was something that was kept very much for the network operations side of things, but increasingly, we're looking at providing a view of the way the network is performing, and indeed a tailored view of the way in which the network is performing for individual users. This is for a number of things. It's to help, obviously, in terms of troubleshooting, but it also has the very strong purpose of providing users with an understanding of what they're actually getting in terms of their own view of the network. The main point of this is really targeted at network operations, so that network operations centers can actually look at performance and look at the end-to-end performance. But at the same time, we recognize that certainly for particular groups of users who have got a cohesive requirement, a cohesive application requirement, they will also have an interest in understanding the way the network is performing on their behalf. And so it's not just about network operations centers. Certainly the network operations center and your own network operations activity is something we'll want to look at this. But it's also looking at the requirements, as it were, from the point of view of user groups who have a particular set of activities that they wish to run. And if you have one of those user groups on your campus, then you'll be particularly interested in the way this is being developed. It is taking a number of existing elements that have been developed in the research networking community in Europe to put together monitoring of a set of parameters. And that monitoring of a set of parameters is at the stage now where we're starting to deploy experimental boxes that are real-time aware so that you can get very precise monitoring and measurement. And gradually that will be built out over the Géant network, and not just over the Géant network, but also there will be boxes available to be placed nationally and on campuses as well, so that you can get an end-to-end picture really from the user to the user. And so this is moving away from monitoring your own network, which is the current picture where each network is monitored independently one of another, And there is really the only picture that you see is an island picture of the network you happen to be managing and monitoring. The intention is to move away from that to have a much more shared information space where you can actually look end to end by putting a consistent set of measurement devices across the network. Now, there is the issue, particularly in the context of the campus, as to how you extend that right within your own environment. The national networks, the pan-European network, you can put measurement boxes on. The challenge, I think, in a campus environment is if you have users who want to see this on an end-to-end basis, how we can incorporate these devices in your operational environment so that you can have a view globally as well. And the intention is to be able to take the measurement points and to have them spread right across the entire networking space, and including there will be some mobile measuring points as well, that enable you to capture data, to capture delay, to capture to jitter and all of these other network parameters, and to make them visible to everybody. And the main work research activity is, first of all, deploying the network data capturing devices, and then building on the data that's been captured to make it available in a way that you can see a specific picture of the network that you're using. And this is targeted partly at the context of network operations. It's also targeted at the power user groups who want to know that the network is performing according to their requirements. High-energy physics is perhaps the best example. But other users who are making significant demands on the network like to understand and see what the end-to-end picture is. And the objective of this activity, of the measurement activity, is to provide that end-to-end picture so that people, both in terms of the network professionals, but also in terms of network users, can see what the overall concatenation of networks is doing on their behalf. And of course, that is only relevant if you can see the picture on an end-to-end basis. So to summarize, what I've covered is really the sort of fact that the change in the backbone network, the move away from a simple IP service to much more sophisticated point-to-point services is an important development which is not just confined to backbone networks. It is a development that affects essentially the end-to-end picture. And if you are going to provide that, then you have to provide significantly improved support. And there are two areas of development work which I think are relevant in this area. There's the PERT, the Performance Enhancement and Response Team, and there is also something which is picturesquely called Joint Research Activity 1. I think it reflects a sort of lack of marketing skill in the research networking community, that we can have something which we call Joint Research Activity 1. And that is actually what network measurement and management is about. If you wish to know more about these three topics, then I would point you in the direction of the websites here. And they actually provide an interesting insight into the sort of developments which will happen, and it's the sort of developments which I hope you will find interesting and participate in. Thank you.
Thank you much, Dyer. I'll take questions from the floor now. Do we have any questions? Stunned silence. Well, while you're thinking of a question, I have a question. What I heard in your presentation is the development of tools to show the state of the end-to-end status of a path across the network. But I didn't get a sense that this was aimed at providing a tool to the end user, like me, for instance.
I think it's fair to say that for individual end users, having a network monitoring tool that is a little bit difficult to justify. What is true is that if you have groups of users who have specific patterns of usage that they want to see observed, so that they're cooperating in an experiment or they're cooperating in terms of general exchange of data, then that is where the tools become specifically useful.
I can just envisage a tool where the user thinks that things aren't working much to his liking, so he runs this tool, and the tool goes and interrogates the network, and it pops up with a message saying, there's this sort of problem here, you should call this person.
Well, I mean, yes, some of those sort of general purpose tools exist obviously today, and the extent to which users employ them depends on the sophistication of the users. But really, I think it's fair to say that performance becomes an issue for users that are demanding, and that implies multiple hundreds of megabits a second as a requirement. Now, what would be interesting is the extent to which, as network performance improves and the network performance becomes more accessible, the number of users that are demanding that and wishing to use it increases, then certainly that will be a big challenge in terms of the accessibility to monitoring tools. What we're targeting today is the relatively small group. Maybe there are 20 European groups of users who are capable of exploiting this now. What is an interesting question is, as that develops and you have more and more individual users demanding it, then it's an interesting question as to whether the networks can actually support that without much more generalized user tools. And I think that will be a good question to come back to in a couple of years' time.
Any other questions? Yes, we have one question here.
One of the discussions we've been having within the UK Light and SurfNet community are the security implications at the campus level of dual homing servers, whereby you have a server connected to UK Light or to Géant 2, but which is also connected to the campus network at the same time for the purpose of downloading operating system patches and so on and so forth. Now, there are clearly serious security implications to doing these sorts of things. Is there anything at the Géant level that you could put in place to address some of these fairly obvious security problems?
Well, I just concentrated on these three particular areas. One is the technology, and the other two is the measurement and monitoring. There are also developments in terms of the authorization infrastructure that you need in order to provide a much more secure environment for these tools to work sensibly, because they are quite powerful and they are capable of essentially creating their own denial of service attacks themselves. So there is a separate activity in terms of authorization, which is actually covered primarily in the area of the mobility work in Géant. And that does feed into and provides the security environment in which particularly the monitoring tools work. I didn't cover it separately as an activity here, but if you look at the aptly named JRA5, you will find that you will see some of the security issues that underpin this work as well.
Anybody else? In that case, I'd like to thank Dyer again and move on to the next speaker. So thank you, Dyer. The next presentation will be given by two gentlemen from the University of Manchester in the UK, and they're going to talk about managing bandwidth on the campus network and monkeying about using all sorts of boxes to improve throughput on critical links. So the first speaker is George Neisser. He'll present the first few slides, and will be followed by Ben Horner, who works together with George. Go ahead.
Hello. Yeah. Thank you, John. Good morning, everyone. This talk is about the deployment of bandwidth management or traffic management technologies on a typical university or college campus in the United Kingdom. What we're going to do is I will describe briefly the strategy and background to all of this, and then ask my colleague Ben Horner here to talk about some of the technical nitty-gritty hands-on work we've been doing in the last year or so. Well, by way of overview, we'll briefly describe the UK educational environment, the network infrastructure, and some of the, in very general terms, some of the bandwidth and traffic management type of problems that colleges and universities have experienced and continue to experience in the UK. Ben will then talk about the technical work we've been doing, the development environment, and focusing specifically on some work we've done with optimizing streaming services using bandwidth management technologies, and finally on the deployment of a Packeteer packet shaper on the University of Manchester campus network in order to manage bandwidth managed traffic. Well, first of all, the operational environment. This is a diagram of the United Kingdom Janet networking infrastructure. You can see there are 8 major nodes, and they link quite a few minor nodes. The whole thing, the Janet network itself links in a number of regional area networks. And these regional area networks provide the connectivity to UK colleges and universities. The difference between a UK college is that a UK college addresses students from the age of about 16 onwards, whereas universities address students from 18 plus. There are far more colleges than universities. More specifically, most of the universities, most of the regional area networks are connected by multi-gigabit speed links. And the regional area networks themselves connect the colleges and universities and many other organizations with slightly less fast links, if you will. There are some 150 universities, over 600 colleges, and many research institutions. And as I say, the links range from 10 megabits per second, which is relatively slow, to many gigabits per second for universities. There are still some colleges in the UK linked into SuperJanet and Janet with 2 megabit links. So these are relatively low speed links, whereas multi-gigabit in universities is actually quite high. There is, generally speaking, an abundance of bandwidth on most university campus networks. This is not the case on many of the College of Further Education campus networks. And there are various problems associated with that. And more specifically, some of the problems that we set about looking at relate to unwanted protocols, some of which may be illegal, on both university and college campuses, an increasingly serious problem. Another general problem we addressed was the issue of critical link and critical segment congestion on campus networks, especially on college campus networks, which might in itself impair the optimum delivery of various types of services. So some of the solutions to this were to evaluate the effectiveness of various bandwidth management technologies in managing the bandwidth on critical segments, on critical links. And we did this specifically with several technologies on the market, Packeteer, Packet Shaper, AlloNet Enforcer, Cisco NBAR, and applied this to a time-critical streaming type service. We then went on to deploy a Packeteer packet shaper on the University of Manchester campus network to control and moderate traffic levels, especially within the student halls of residence. And in a few moments, Ben will explain the results and exactly what we did. And I will now ask Ben to come along and just...
Right. Good morning, everybody. My presentation is going to come in two parts. The first part is going to be talking about my work with the Janet Bandwidth Management Advisory Service. I'm going to be talking about the colleges that approached us, the problems they faced, and then what we could try to do to help solve those problems. And then after that, I'm going to talk about my work with the university campus at Manchester and how we've managed to certainly drastically reduce the amount of wasted bandwidth on our campus. So, to start with, the streaming trials basically came about because we were approached by UK colleges who are introducing virtual learning environments, and they obviously want the best on the market, and so they want things like streaming media. The biggest problem with that is that it uses a lot of bandwidth, one thing they don't have. Say they have something like mechanical engineering. The streams will require a lot of detail, so you need a high bandwidth stream, maybe 350k a second, 512k a second. You have a class of 30 students, pulling that down across a 10 meg link, you can see that it's easily saturated, and things like general web browsing or any other research going on is going to struggle to get through. So we've got to find a way to promote these kind of time-critical applications, but at the same time allow for the other things to get through. The three solutions looked at were the Packeteer Packet Shaper, the Allot Net Enforcer, these are products that are available in the market now, and also the Cisco NBAR, which is network-based application recognition. For those who don't know how it works, it's built into quite a lot of Cisco's kit, switches and routers, that is able to do some level of packet inspection, so it's not based just on ports, so things like Kazaa that can jump ports, it's able to pick that up, so if someone pushes Kazaa through port 80, you can still find out what's going on there and then apply quality of service to it and give it certainly less than best effort or even stop it coming through at all. Then we draw conclusions from this. We see the number of packets that can come through from the streams and general human perception as well. You sit in front of the video and you actually see, is this video watchable? Would you be happy if you were a user watching this video? So, how we did these tests. Here's the network diagram. It's fairly complex to go through, but I'll use my new toy from the gala evening last night. Basically, there's two sides to the network. The first side starts here and comes around here. This is basically the side that all the servers reside on. We've got a server cluster here that has two Windows 2003 advanced servers. One server is running with a real Helix server. A real Helix server can serve real media, QuickTime, and also Windows Media. Though its Windows Media support is not fantastic because they had to reverse engineer the codec to be able to get it to work, but they are working on it, and it certainly is improving. From the servers, we served across a simulated 2 megabit WAN link, and then through into the bandwidth management device. This is where either the packet shaper would sit or the Allot Net Enforcer. One thing to note is that the Cisco NBAR can only reside before the bottleneck. We tried to apply it after the bottleneck and found that it wasn't able to get information back to the servers to tell them to slow down. But with the paid-for devices, the Allot Net Enforcer and Packeteer, they are able to basically manipulate TCP window sizes and therefore slow down non-time critical traffic. Then from the bandwidth management device, we have the cluster PCs. These represent the actual clients. These are just Windows XP Service Pack 2 boxes running the standard real client, Windows client, QuickTime client. So these are our results. Hopefully you can read these up at the back, but I'll give you a quick run through. The first section is where no shaping is applied. The bottom section of these graphs are the media streams as they were run. You can see there's 5 very distinct streams in each one, and obviously increasing in bandwidth. The first streams were run at 56k, the second at 128, then 256, 512k stream, and then finally there was a stream that was multi-bit rate, which is one file but contains all the bit rates, and so if you don't have enough bandwidth, it can drop back down. So as you can see on the no shaping, here's HTTP and FTP traffic. And if I go back and show that here in the middle is a LandForge box. This is able to generate traffic for us. It can generate any rate of traffic you want. So we told it to produce 1 megabit of HTTP and 1 megabit of FTP. So that basically saturated a link for us. So you can see here, my pen died, there we go. We're getting 1 megabit of each traffic, and the total traffic is at 2 meg consistently throughout. Obviously, with no shaping going on, the streams did seem to get through, but also it's quite surprising that we found that only a small amount of packet loss with these media streams can result in a very large degradation in the quality of streams to watch. So these things are extremely important to get through as much as possible. First section is at Cisco NBAR, and then as you can see, the graphs definitely improve, and the 512K stream was certainly able to get the required bandwidth through. One thing to note with the Cisco NBAR, it's not particularly well documented at the moment. There's a lot of documentation about how to restrict, say, virus traffic, but certainly not much towards streaming. But it does support the streaming protocols such as RTSP. Then the packet shaper and net enforcer. One thing was interesting to note was that the overall traffic levels dropped. I couldn't really get a straight answer out of both companies to find out why that was, but I think it's mainly behind them reserving a small amount of traffic for things like routing updates to get through, and also being able to manage the box under high load. And as you can see, both performed very well, and possibly better than the Cisco NBAR, and the reduction of FTP and HTTP traffic was much neater. The second one is Windows Media from the Real Helix server. Like I said, the Windows Media support on Real Helix isn't fantastic. It's able to support the single bitrate streams. When it came to the multi-rate streams, it seemed to struggle a fair bit. And we definitely experienced packet loss on these, but Real do promises that they are going to improve the support. As you can see, with no shaping, again, Windows Media did struggle, certainly. And the HTTP and FTP managed to get through and severely degrade the quality of the Windows Media streams. Then we have the Real Media from Real Helix server. Obviously, Real Media coming from its own Real server is going to perform a lot better than the Windows Media, and you can see that, again, it manages fairly well. Also interesting is the fact that with no shaping, the Real Media was able to handle much better than the Windows Media with no shaping. I'm not quite sure how Real managed this, but it does seem to be able to work better under congested links. Another thing to see here is the net enforcer struggled with the Real Media. This seemed to be that the net enforcer at the time, its support of being able to recognize the real traffic wasn't particularly good. But again, I've been promised by net enforcer that since these trials took place, they have improved the quality of the recognition. Finally, the QuickTime. You'll notice there's only 4 graphs. QuickTime doesn't support multi-bit rates, it's only single bit rates. So you've got the 56, 128, 256, and 512. Again, these graphs look as if a fair bit of traffic's getting through, but it is very surprising that even though, say, 80% of the traffic gets through, it's a stream that's fairly unwatchable. It'll stutter, the video will disappear, suddenly you'll jump a minute ahead of yourself, and for watching it, say, a lecture like this, it would be very difficult to follow. And then very similar results, it was able to be handled fairly well. The Cisco NBAR did perform particularly well, considering that it's something that's built in for free on most Cisco iOS. So you may be thinking, how applicable is this? That it's only 2 megabit links, these are fairly small. But this kind of thing is very scalable. These problems that the colleges are facing are definitely going to be faced by the universities and the people with the gigabit links. I think it was said earlier that the reason maybe we're not using all our bandwidth is because we're not providing enough. And as soon as we do provide enough, they're going to use it all. Things like HDTV are coming in, and obviously that's going to use up a lot of bandwidth. So we realised this at the university. We basically connect our student halls directly onto campus. We have around 11,000 wired rooms. Obviously not all these rooms are on at the same time, but we can have anywhere between 3,000 and 5,000 students on concurrently. They're all connected through 10 megabit half duplex links. And obviously they try to use as much peer-to-peer as they possibly can. And that's why we installed a Packeteer Packet Shaper. It says here it's 9,500, but in the past 2 weeks we've installed the 10,000 to accommodate more students, as we're definitely going to be expanding after our merger with UMIST. The arrows aren't indicative of the actual flow direction of the traffic, but more to show where the requests that the students make go. So if a student in halls makes a request for the internet, it has to go through the Packet Shaper and out through the gateway for University of Manchester and onto SuperJanet. But if they make a request for something campus-based, then this traffic isn't shaped and so they can get full line speed. The kind of restrictions we applied were things such as peer-to-peer. This was a massive reduction in traffic use. And a lot of the network managers, when they saw what was truly going on the network, they were very surprised. I think a lot of people don't quite realise how much is going on. I saw in a lecture, I think it was on the first day, that some places have 69% unknown. So you can monitor the ports, you can see that port 80 has 10% and FTP has 5%. But it's astonishing when you get this kind of visibility, what is actually going on your network. Peer-to-peer is basically restricted to the fact that it does not work. We basically decided to turn it all off. It's a bit of a difficult issue because obviously there are some legitimate uses. Things like BitTorrent can be used for getting hold of Linux ISOs and things, but I think we all know that the majority of it is going to be for illegal use. Virus propagation and anti-DOS. This certainly, the virus propagation was blocked through this, the general Windows exploits, the port 445 and things. That basically those kind of NetBIOS things don't really need to connect to the internet, so we can block those. Anti-DOS, I'll come on to a little bit later, but it's extremely useful. These students that put their own PCs in halls, they can arrive in behind the firewall, their own managed desktops. They can come in infected with a number of viruses already. So obviously we need to find a way, because these could be compromised and then used as a DOS attack out towards someone else. So it's not only protecting ourselves, but it's protecting other people from us. And then also blocking internal non-sanctioned HTTP and FTP servers. We found a couple of students that were running HTTP servers and FTP servers that were serving things like Whereas, and so we basically decided to just turn them all off. And if you want to run a server, you have to come to us with a justified case to say, I want to run a server, this is why, and then we can give access. The more advanced features we use it for, Top Talkers and Listeners is very useful. Every Friday I send the manager over at the campus halls basically a detailed list of what are our top 10 IPs that are using the most bandwidth that week. What protocols are they using? One very interesting thing we found was that a huge number of students were using a thing called cool streaming. It's recently been shut down because of copyright issues, but if you look around, it's still available. It basically runs just like BitTorrent, but it streams live TV, and it can stream things like ESPN and a lot of things that obviously people want not to put on the internet. And also with it running like BitTorrent, not only do you bring in traffic, but you also serve out traffic. I ran it for 5 minutes and found that even with me not watching any video, I still act as a node because it recognizes I have bandwidth. It would bring in, say, 300K a second, but pump out 1 megabit a second. And you think 3,000 students pushing out that kind of thing, it's just going to eat all your bandwidth up. So it is something we have to watch. And when we did the Top Talkers and Listeners, we found that 50 megabits a second was going out in real media. And we thought, oh, God, someone's got the real Helix server license. That's $20,000 worth of license. So he ran around and you have to go to the students. And I think that's one very important thing with the network monitoring, is maybe don't just concentrate on what the graphs tell you. Speak to the users, find out what they're using, look on the PCs. And a lot of them seem to be fairly willing to say, I'm using this application. And we went to them, we found cool streaming, and luckily it was that and not a real Helix server that had been ripped off the net. And so what we decided to do was shape the traffic in a way that they could still watch the television streams, but serving out was restricted. We restricted it down to only 50 people could serve 100K a second each, and that was it. And obviously, maybe we'll restrict that more in the future if it causes more problems. The packet capture. Andrew Cormack yesterday made very good points about the legal implications of this. And I think it's very important to make sure you have a real justified reason for doing this and know what you're going to do with this data. It's mainly used at the university for things like we still have around 15% of unknown traffic. And so we have to run packet captures to try and figure out what that is and then feed that back to Packeteer so maybe they can then create a class for it so we can shape that traffic more effectively. Now, Adaptive Respond, I mentioned before the anti-DOS. This can work in a way that we don't have to be at the box for it to react to traffic patterns. So if the box suddenly realizes that a certain class is serving out huge amounts of traffic, or maybe millions of packets per second, the box is able to create a class for us automatically, shape the traffic down to a still usable amount, so if that traffic is legitimate, it can still get through, but it's not going to steal everyone's bandwidth. It can send myself or a group of us an email, and then when we come in the morning, the user's still got their traffic, and we can then make a human decision on that rather than the box just either turning it off or letting it all through. And it's been very useful just to certainly control traffic that is turned up whilst you're away on holiday or it's the weekend. And then custom classes, that's what we did for things like the internal HTTP and FTP servers. These things don't come as standard on the box, but through the web interface you can easily set up a restriction that says find all HTTP servers that are inside my network and then apply these rules to them. It's very simple to do. So, conclusions. There's a lot of future work to do. It seems like network monitoring has been a real hot topic at this conference. And I think a lot of us really want to know exactly what's on our network now. And bandwidth is going to increase, but so will the hungry applications. These things like cool streaming. I think this is the first one I've seen, but I think it's certainly something we'll see as, oh, that's quite a useful application, I'll make my own. BitTorrent started fairly slowly, and now it's absolutely huge. And also things such as Skype traffic. Skype runs in the same way that Kazaa does. So you have things like supernodes, and again, it's the same problem with cool streaming, that not only are you serving your own traffic, you're also serving out lots of other people's. And obviously, students in university halls, they have nice uptime 10 megabit links, and Skype will use them as much as possible. There's things such as voice over IP, video streaming, the remote collaboration, and video conferencing. These things are now being built into standard on Windows. MSN Messenger now can do video conferencing, and one day that will most probably go to HD TV quality, and the bandwidth will certainly go through the roof. Now this is BMAS is ending. Basically, the service will be finishing in the way that it is at the moment. We certainly won't be looking at products in a more proactive way, but in a reactive way. So I think it'll go to a service where if we're contacted, we'll then go away and do the research rather than researching and then providing findings. But the main point is that bandwidth management requirements are going to continue and are definitely going to get bigger. The bandwidth will increase, but so will the applications. And I think we need to definitely keep an eye on.
Okay, do we have any questions from the floor?
Have you tried to assess which is cheaper, giving the students more bandwidth than doing this traffic shaping? And if not, what is the driver behind all this work?
I think it's the age-old problem. If you give them more bandwidth, they'll just take it. I think throwing more bandwidth at it isn't the solution to the problem. A lot of the shaping is required just to provide general quality of service. You've got to make sure that this traffic can get through when it needs to get through. So I don't think throwing more bandwidth at the problem will solve it. If anything, throwing more bandwidth will probably cause more problems, I think.
What sort of evidence do you have for that? Because I was going to ask this heretical question. Why do all this monkeying around with special expensive boxes? Are they expensive?
Yes, but then things like Cisco NBAR will be free. If most versions of Cisco IOS have it available, you can just type in a set of commands and you can run the basics. So if you want to restrict things like Kazaa, You know, you can go away and do that on your campus now.
But restricting and blocking is one thing. The traffic shaping is something else. And,
yes.
And to me, extra bandwidth seems like a good solution.
Sorry, can I just say that there is a conflict in many colleges and universities in the UK between buying in more bandwidth or applying bandwidth management, and the whole thing is still in flux. Some will argue that we'll just throw more bandwidth at it, whereas others will maintain that we need bandwidth management, traffic management. So there is a tension at the moment. I'm not sure how it will resolve.
Well, that seems like going back to the days when the network was the scarce resource to me. So,
I mean, traffic management will be required in certain instances, as Ben says, for quality of service and in critical links, critical segments. But there is a conflict, we agree, and I don't think it's been resolved.
Also, it is a scarce resource for people like the colleges, that we're not all, you know, the universities that have these nice gig links, that some of them are on 2 meg. You know, I have 2 meg to my own flat, but they're sharing 2 meg to a college. So it certainly is a scarce resource for some people, definitely.
I'd agree, but maybe the right thing to do would be to address that issue.
Yes, maybe, yeah.
Any other question? One question here.
You mentioned how you were trying to protect video streams from virtual learning environments servers. Mm-hmm. Did you investigate the possibility of getting some of that traffic multicast so that you only had one incoming stream over the 2 meg link?
No, it would be useful. One problem we did face was that certainly in the colleges, it's a huge variation of what the network managers know. You can go to some colleges and the network manager is the caretaker. You know, you say, you know, where's your Janet link? And it's just sat in a cupboard somewhere and it runs and there's no management. So to ask them to implement something like multicast would either need a lot of training and spending on people to make sure that the network managers know how to do that, or possibly, you know, maybe involving the universities and providing that kind of service for them.
Okay, thank you very much. Excellent presentation, thanks.
Thank you.
I'd like to introduce our last speaker of the morning, and he's Victoriano Giralt from the University of Malaga, talking on privacy-enabled directory services. I have 2 things to say about this presentation. The first thing is that I promised to expose some of my attributes, so I'll do that right now. Incidentally, Diego got into this sort of trick, didn't you, in the Internet 2 meeting? So, right, this is definitely relevant for the presentation. The second thing I'd like to say is that Victoriano has promised a special gift to anybody asking him a question at the end of this presentation. Maybe we should limit it to sensible question, huh? Yeah. Relevant question.
That's right.
So in that case, I'll hand over to Victoriano and let's hear about the security enabled directory services.
Okay.
Thank you.
First of all, I'd like to ask for your to beg your pardon, because having 4 native British-speaking accents in this session, my English will sound very strange. Yeah, I'm not very good at it. And thanks to all in the know for wearing the T-shirts. Okay, let's go ahead. My presentation will have 2 parts. The first is most marketing, and the second one will go into the innards of the thing. We have a problem. That's a clear problem. We have a problem of confrontation of interests that comes from the institutional state of our institutions, what our users' needs, the legal matters, and the technical requirements. So we had to find a solution. We took 2 approaches that we will see soon, and we implemented the best of both approaches. The institutional mandate says that public institutions must serve the public. So, these institutions must give out information about themselves to the general public. They should offer also information about their own members, and these institutions should collaborate. As we can see here, we collaborate, we have a wonderful network. But users have needs. They want to find other users for communicating with them. They also want to be found by possible partners for their projects. It's very interesting. I'm working in such a field, say biomedics or bioinformatics, so I want everybody to know. But those in the field, not the spammers. That's why they do not want their data exposed. So there's a big confrontation of interests that's difficult to solve. And to add insult to injury, we have people's right to privacy. We have legal matters in here. So persons have the right to conceal their data. There are two schools that say those who work in a public institution, their data is not private because they are public servants working for a public institution. But there is another way of thinking, there's another line of philosophy in this, that say that any data is private. And in several cases, like Spain, internet searchable directories may be considered international transfer of personal data, and that is against the law. So we had an interesting problem. Then we had another problem, that the directory may be accessed directly, because people like to configure their mail clients in order to find mail addresses. Or they like to configure whatever. They have to find phone numbers or anything. Then we cannot work at application level. So we must enforce the policy regardless the access method we are using to access our directories. And we need to treat differently both coming from inside our organization and those coming from outside our organization. It's not the same. I have the right to find a colleague's in my institution phone number, but any of you not belonging to my university, if this person doesn't want to be found, then you may not find them. And of course, we are technicians, we have to administrate these, and then we decided that reducing the administrative burden would be a plus in the solution. We took a first approach. We asked the lawyers, and they proposed ditch the directory. Real. We went to the users, and they say, we don't care. We just wanted it to work. Whatever it means. We want it working. We don't care. And then technicians proposed, ditch the lawyers. Of course, we couldn't do that, so we had to find a second solution. Our solution needed to put control on the hands of the user, let the organization define the policy, and of course, we should abide by the law. It was most important. So we had two sides of a coin. We have the user side. They must have control of their data. We have the server side. This is important. The solution must work whichever the interface to access the directory. So we had the user side interface for setting user preferences. That's easy. We know what to do. Create a nice web form. I will show it. Then we needed somewhere to store user preferences. And here comes. It is user private attribute. The user uses that for setting preferences. Then the institution needed to set the policy, and I should enforce that, whatever the interface. So that's why we discarded application level control. There are some people that say this does not belong in the directory, but if we do not it in the directory server, then you don't have privacy control if you have direct access to the directory. Then we have to enforce policy at server level. That's why open LDAP ACLs came in our aid. So, this is the end of the marketing part of the presentation. User control of personal data. That's clear. And I will see how they do this. Policy is enforced at the server level. Lawyers seem happy with the solution, which is a very important part of this. The solution is simple, and even it works. So, let me show how we have implemented this nice solution. Well, I think it's nice. We had the idea. Then, as you see here, there was a pointer, yeah. It is user. We have two policies, one for students and one for non-students. The student may have the private attribute, may have a value of entry, and then that's deny access to all attributes. Actually, it denies access to the whole entry. If you look for a student who has not decided to show her data, you will not find this person in the directory. The entry will be absolutely hidden. You will not know this person is student and is studying at our university. Then, if this person, yep, that's right. If this person clears the, just a minute. As you see here, the filter says, if the edu person affiliation is a student, then, and it is user private attribute says all, then whole entry is concealed. If this person simply is a student, this is behind the previous rule in the ACL, you know, they are applied a top-down process, then these attributes, the entry, we need access to the entry to get the attributes, then only display name, mail, and phone number will be visible to people querying the attribute from outside, querying the directory from outside our university. In case of people working at the university, we took a different approach. But we have a special policy that we can conceal entries in case we need it. For example, there are some Spanish universities where some professors have been menaced by terrorists. So you may not show their entries. So we can hide full entries, giving the attribute entry to the iris user private attribute. Okay? Then, anyone can decide which attributes to show or hide from a set decided by the organization's policy. Then, user private attribute holds the names of such attributes. For example, if we want to block access to the phone number, we put a value in user private attribute saying telephone number. Then attribute telephone number may be read by people who has bound to the directory. You have identified to the directory server, you have given your password, so you are a member of the institution, you can find the phone number. But if you have not, you are an anonymous user, then you may not see the phone number of this person. or the person may decide to hide all attributes. This is in the part of lowering the administrative burden. We could put all attributes in special filters or many values, but we decided that it was much easier to administrate if we had an all saying everything is hidden except for our users. Well, and that's it for the technical part. And then let me show you the user part. Oh, I shouldn't. Oh, what's that? Tag is yes, I think. Well, what's that? What's happening? Bye. But I've asked for Internet Explorer. I expected this. I wanted to project using the Mac, but it was better using these. So I preferred not to plug in my Mac, though this will erode my image. But this has come to my rescue. Windows has banged as usual, so it's fine. It's good for me. I approach a Windows machine and it bangs. It's wonderful. Excuse me. Well, I will just show you a nice web form, and I will show you it at work.
Is this, just while we're waiting, is this system implemented as a production system in the University of Malaga now?
Yes, I will show you.
Okay.
We will query our server. We will go to the university.
And will it be used across Spain, or is it just University of Malaga?
Well, I hope it will be used across Spain. It's difficult to convince my colleagues. It's been very easy to convince the people in Croatia. They have adopted the idea. Thank you. But, well, you know that it's been invented in Spain, so we have some Spanish strange things. It's absolutely in Spanish, but the idea is showing off, so no problem. I think there's an English version, but I'm not in charge of the context. What's this? Oh.
It's Windows helping you.
But someone is managing this thing. Yeah.
Bill's at the bottom of all this.
Oh, what's it?
No, no problem.
Great.
Yeah.
So, this is my entry, as you can see here. This is me. This is my email address. It's very well known around the internet, so there's no point in hiding it. And I can go to the groupware system. It's in a beta state at this moment. We are deciding if we will keep this. What says this? Okay. Okay. Tack. My Polish is improving. Tack. And now, here it is. Now, I go to the I typed properly. Yep. It's not the fastest groupware we have found, so we are in the process of looking for a faster one. But it's nice. Hey, come on. Yeah, nice. So, we are waiting for a lot of icons here. I'm the administrator of the thing, so I have many icons. And here we are. I can go in here, and you see here, this is my name and surname. For the people in the know, is CN and SN1 and SN2. My description or my phone. I can decide to hide my phone. I ask for changes. Will it bang on me if I open another Internet Explorer? Click. Norway. Okno. That's window. Oh, wonderful. Tack. Ni. I want to go to the other side. It's nicer with Firefox. Tack. with Firefox tabs is very nice because you can use 3 tags and tabs, and it's wonderful. We can go find me again, and no phone number. It's very quick. It's very nice because you can do it in 2 screens at the same time, and it's wonderful. You see it disappear. And I can show you that if I go here and query the directory from inside the groupware, then, come on, are you sleepy today? It's Dad from Poland. If I query the directory for me, I hope it should work. There's my colleague in charge of these over there. If I look for me, here it is. There's my phone. Because I'm inside my organization, I'm entitled to see that phone. It's my work phone. So anyone in my organization has the right to look for my phone. Okay? You see, it's simple, but the old saying says, keep it simple, it's stupid. And that's all. I think I've been even faster than expected.
Very good. Very good.
Thank you.
Very good. We get coffee early, but first of all, thanks for the presentation.
Thank you.
And now for the questions.
Remember, any sensible question will get T-shirts. Oh, Miroslav, you have one. You have one.
Medium's not going to work, is it?
No.
I do have a T-shirt, but it is too small for me.
But it's XL. I can get one bigger.
Okay. First, you have sold your idea to Croatians, but only for testing purposes. So we did not implement it yet. Although the privacy attribute is in Croatian edu schema. The question is on scalability and the fact that how big the directory is where you have implemented it. You are using the filter stuff, so this means there is additional burden, additional load on the LDAP server for doing that. So kind of figures and information on that would be interesting.
We have actually not noticed any degradation. We are working with some 50,000 entries, and I had a talk with Mike Getters from Duke University about this very problem. And he proposed a nice idea, and it's real. He knows the directory innards working. So these filters are applied afterwards the search. You search for entries, and as you have set up controls in the number of entries, you get back. Once you get back the entries, then the filters are applied. So you're querying for a lot of entries, you get, say, 50, 100 entries, and then is when the filters get applied. Then there's no performance issues apart from the normal searching and querying issues. Okay? Thank you, Mira.
Any other questions?
You want your T-shirt? Ask the question.
You don't have to disclose your size attribute, okay? I'll guess.
This is actually more a question about LDAP in general rather than your system in particular. But can LDAP be adapted to any type of information that is hierarchical in nature, or is it really just limited to this type of, personal information about people, or can you extend it to any philosophy that has a hierarchical nature?
I love that question. because Diego will be also very happy with this question, because we are working in another project that we will present next year, well, not here, but we will start presenting it next year, about classifications. We have, our directory is very, plain, very leveled. We have only 5 branches. And we have, a colleague of us has decided a very nice classification structure. And we are preparing a geographical location for people. We will have an application that you can query and find the office where this person is located. We are developing it with, together with the people in charge of distributing mail in the university. And then you can query and say, I want to find Victoriano, and they will get, you go to this building, then you go to these, I can't remember, this part of the building, then you go to this floor, and then you go to this office, and even we can go to the desk if we are able. And we are even thinking on getting GPS information, then you can get the waypoint. So using classifications is quite easy to put the hierarchy inside.
The reason I asked this question is that the glyph, which is the global ensemble of light path networks, are currently thinking about how each country can publicise its own resources in terms of number of gigabit Ethernet connections available for carrying transit traffic. And maybe we can talk offline about whether your system could be extended to the glyphs activities.
Yeah, of course.
I'd very much like to be involved in that conversation.
Of course. Now the
Hello.
question.
Can I ask, what are the security ramifications of... Sorry, I'm over here.
Well, I can
Here.
see you. Oh, great.
Sorry, can I ask, what are the security ramifications of having your directory available for change across, well, as in this case, from outside the organisation? Has anybody actually attacked your service?
No, fortunately not. I'm not sure if it's due to a visibility reason, but well, it's protected behind, as you have seen, HTTPS, and you have to provide your credentials. Up to the moment, it's simple password protection, but we have not seen any attacks.
The next question is, can this also be used to actually change the data, such as when a user migrates from, say, one office to another, can they actually change their data within the LDAP rather than just the attribute for displaying the data?
They will be able to do that. It's in development stage. They will be able to do that. And we intend that, because we have detected a big problem, that the mail get lost. Because of this, you have an office, you move office, and then nobody finds you. And then mails waits for you in, say, 1 week, because it went to the wrong office. Maybe you have changed buildings, so the mail is going in rounds around the university. And that's the idea behind this location system. You have the right to change your location. Of course, we will log that change. In case someone changes someone else, or someone is playing, we can say, well, you're playing idiot, so...
And you kind of touched on sort of my next question there. I'm not a huge user of LDAP, but what are the security ramifications of one user changing another user's attributes?
Well,
is that I know you're the administrator, but...
It wouldn't be, in theory, it wouldn't be possible, because you have these nice ACLs, and you only give right permissions to the owner of the entry and to the administration system. So they work very well. That's why we went this route, because they work very well.
Thanks very much.
Thanks to you.
So he gets the T-shirt. He said the keyword security. But my question was a little bit directed in another direction. Security of the system as a whole. In Germany, if you have personal data on a server, you have to secure the computer very good. Personal data is the best secured data we have. So, did you think not only about HTTPS to secure the server in general?
Well, the server is only available through LDAP protocol, because we have decided to keep it open for reasons. Fortunately, we have 3 levels of personal data in Spain. Level 1 just need, this data is level 1, so it just needs normal procedures for protection. Our servers, we have 1 server where you can write, and 2 replication servers where the queries are done. You can only access them from outside on the normal LDAP port. We're in the process of moving it to secure LDAP, but we are not so sure because of the clients mostly. And that's the only way to access them. They have nothing on them apart from the LDAP server, and you cannot access them from outside, even from outside our production network. They can only be contacted by some servers for the queries and for administration. They are completely hidden behind a firewall.
Okay.
Yeah, one more question. As far as I understand, right here, as far as I understand, your LDAP service is quite integrated with the groupware system of the university. Isn't that right?
Yeah. Well, I'm not sure if this groupware you have seen will be the groupware of the university, but it's a complete. Our idea is to completely integrate everything over LDAP.
Okay, but well, I mean, LDAP directory service can be sort of separated. It can be used by any groupware, if you like it. But did you test it with other production groupwares, like First Class or whatever?
No, we started testing this one. We are in the process of deciding which one we will use. So this is the first one we are testing.
Okay, thank you.
We have time for one last question before coffee.
It's more a remark than a question. When Victoriano was mentioning about, answering a little bit more to your question, we are involved in a harmonization project for schemas that we call SHAC. And instead SHAC, we want, and we are proposing to include these attributes also, not only to make the system aware of the privacy requirements and to avoid the data leakage, but also in order to being able to publicize why you are not disclosing a certain attribute when you are asked. So somebody that has a certain trust, somebody that is trusted is asking you for example, the gender of somebody, and you are saying, no, I can provide this attribute because it's forbidden. So it's the other side of the applicability of this.
Thank you for those comments, Diego. And with that, I'll close the session, and I'd like to thank all of the speakers once again. Thanks for an excellent set of presentations. Thank you.